Alright, so looking at the calendar, obviously we missed yesterday. We just bump everything back a day, and that review day we had built in becomes finish up related rates that day, and then we'll test on Tuesday. Again, only 2 topics and the related topics, so I think we'll be okay for the test on Tuesday. All right, it's been a couple of days now, but let's do some from page 146. Make sure we're okay with those. Or I guess it's page 145, should have said. Questions from those? Mark? 15. Y equals sine of xy. Find dy dx. So take the derivative of both sides. Left-hand side's easy. Dy dx. Right-hand side. Sine of something. Mark, what's the derivative of sine? Cosine. So cosine, the something stays the same, and then chain rule will multiply by the derivative of xy. Well, the derivative of xy, that's going to require the product rule. F and g, f prime would be 1, and g prime would be dy dx. So f g prime x dy dx plus the other way around y f or g f prime would just be y. And solve for dy dx. So our calculus is done, but there's still algebra to go. I need to get dy dx by itself. Well, and there's 2 of them, so let's distribute cosine of xy. So x dy dx times cosine of xy plus y times cosine of xy. I have 2 terms with dy dx, so I want to get those terms on the same side and then factor them out. So I'm going to subtract over this term to get all my dy dx's on one side. So dy dx minus x, and I'm going to rewrite it. I'm going to just change the order here, times x cosine xy times dy dx equals y cosine xy. Alright, we picked it up from here before. Let's factor out the dy dx and divide by whatever's left. So factor out dy dx. That leaves 1 minus x cosine of xy. And then divide by all of this stuff to get dy dx by itself. Kind of back up and look at the whole picture here. Let's see, we did a calculus step, and then another calculus step. So we did a trig rule, and then we did product rule, and after that it was all algebra. So a little bit of calculus and a whole lot of algebra. And you've picked up on. That's a recurring theme in here. A little bit of calculus at the beginning and then a lot of algebra after that for a lot of these problems. Other questions? Let's do a couple more. Connor? 33 or 35, because they're probably pretty similar. Let's see. 35 would be I think I want to do 33, because 35 is xy equals 1, so that would be, I said I want to do 33. Let me briefly do 35, but not all of it, and then we'll do all of 33. 35 is going to be the product rule that we just did. The product rule on xy. That's exactly the same product rule we just did for 15. So that would be, let me do it the same order here. X dy dx plus y times 1 equals 0. So dy dx equals negative y over x, and then you go from there. Let's do 33 sort of all the way through. Sometimes a little bit different. Y minus 3 squared equals 4 times x minus 5. And the directions say, find an equation of the tangent line at the given point. So I need slope, which means dy dx, and I need a point, which they give me, 6, 1. In fact, I could go ahead and say I need the slope at 6, 1. So I need the slope, the derivative at 6, 1. I'll use the point 6, 1, and then I'll be able to write the tangent line. Let's see. I could do some algebra on this first. I don't think I want to FOIL this out, because then I'm going to end up with y squared minus 6y. I'm going to have 2 dy dx's. I think I'm best to leave this one as is. But I think the other side, I think it'd be easier if I distributed the 4. I don't have to, but I think it's just going to work out a little easier. Alright, so let's take the derivative of everybody. So the derivative of y minus 3 squared, the derivative of something squared, is 2 times the something to the first times the derivative of the thing. And the other side is easy. The derivative of 4x minus 20 would be 4. So dy dx equals 4 over 2 times y minus 3. Or just 2 over y minus 3. Simplify a little bit. So that tells me the derivative at any particular point. But I need the derivative at this particular point so that I can write the tangent line there. So let's evaluate this at 6, 1 to find the slope at 6, 1. And we've discovered this already. Sometimes you need the x-coordinate, sometimes you need the y-coordinate, sometimes you need both. This one we only need the y-coordinate. 1 goes into y. 2, that's a safe stop, but since there's more to go, I think I'm going to clean it up a little bit. 2 over negative 2 is negative 1. So now I've got my slope and my point. So y minus 1 equals y minus 1 equals negative 1 times x minus 6. my equation of the tangent line. What else?
27 and 29.
27 and 29. Tangent. Tangent of x plus y equals x. 0, 0. I guess I should read the directions then. Find dy dx by implicit differentiation and evaluate the derivative at the given point. So I need to have two answers here. I need dy dx equals whatever I get, and then I need to plug in 0, 0. In fact, maybe I should. It's not really necessary, but this is what it's asking me. Find dy dx, and then find dy dx at 0, 0. So I need to have both of those things as my answer. Obviously, if I get the first one, the second one should be relatively easy. All right, the derivative of tangent of something. So forget about the something for now. What's the derivative of tangent? Secant squared. So secant squared of the something, so x plus y stays the same. But then I need to chain rule that and multiply by the derivative of x plus y. What's the derivative of x? And the derivative of y? Dy dx. And then the other side, the derivative of x, is just 1. And so my job is to get dy dx by itself. My calculus is done, and now I've got to do some algebra to get dy dx by itself. I think rather than distributing, I think I'll divide. That way I start to get this stuff by itself. So 1 plus dy dx equals 1 over secant squared x plus y. I can leave it like that, but what's 1 over secant? Cosine. So I don't know what CalcChat does, and I don't usually mess around with trig, but if I can change 1 over secant to cosine, that seems to me like a good deal to do. And then I'll subtract this 1 over. So there's part of my answer. That's the first part of the answer. And then to evaluate that at 0, 0, oh, that's a safe stop, so it can be done. Let's see, the cosine of 0 is 1. 1 minus 1 would be 0.
Can you do like 17 or 19?
Yes.
Those have a bunch of steps.
Okay. Oh, those look pretty similar. So you got a preference on one of those? I guess 19 looks harder because there's minus sign involved. So we'll do 19. But they look pretty similar. They both have an x squared and a y squared. So I bet they work in a similar fashion. And Emily, we'll come back and get 29. So 16y squared minus x squared equals 16. Anybody remember what shape that is? Y squared minus x squared? Plus would be a circle or an ellipse, but minus would be, pre-cal experts, it's the other one, yeah, good. Hyperbola. So I don't know if that matters to this problem, but maybe it helps us make sense. Let me read the directions. In exercise 17 through 20, find two explicit functions by solving the equation for y in terms of x Okay. Differentiate the explicit functions. Find dy dx implicitly and show that the result is equivalent to... Okay. Here's what they're asking. I should have clarified on this before we got here. They want you to find an explicit function for y. So let's solve for y, and then we'll take a derivative, as opposed to taking a derivative from the get-go. So y squared equals x squared over 16 plus 1. If I square root both sides, what do we have to remember when we put the square roots on? The plus or minus, and that's why it says find two explicit functions. Because it would take two functions to show the graph of that original equation. This original equation is not a function. Yeah, our hyperbola is not a function. And when we break it into two, that kind of makes sense. We get the top branch and the bottom branch of the hyperbola. Find two explicit functions by solving the equation in terms of y. Okay, did that. That's part A. Part B, sketch the graph of the equation and label the parts given by the corresponding explicit functions. Oh, I did that as well. The positive one gives me the top half of the hyperbola. The negative one gives me the bottom half of the hyperbola. Differentiate the explicit functions. Well, they're close enough to the same, so this shouldn't be too bad. It should only be off by a minus sign. Okay, that's not differentiated. That's algebra, because I don't take a derivative of a square root. I take a derivative of a power. So dy dx equals 1/2 x squared over 16 plus 1 to the negative 1/2 times, chain rule, derivative of x squared over 16 would be 2x over 16. So if we clean that up, let's see, the x's would cancel, or excuse me, the 2's would cancel, the x would stay on top. This 16 stays in the bottom, and this negative would send that to the bottom. X squared over 16 plus 1 to the 1/2. That was this first one. What would be different about the second one? It'd be negative. Everything else is the same. So I'm just going to say put the plus or minus on there. So that was part C. Part D, find dy dx implicitly and show that the result is equivalent to part C. Okay, so that's part C. Now it wants us to come back up here and do the implicit differentiation and see if we get the same thing. So 32y dy dx minus 2x equals 0. So dy dx equals, see if I can do all this algebra at one time, move the 2x over, divide by 32y, I get x over 16y. So the claim is that these two things are the same. They don't look the same. They both have an x and a 16, so maybe. This one has a y and this one has this expression. But way back here we figured out what y was equal to. It was equal to plus or minus square root x squared over 16 plus 1 So if we plug that in for y, then they are the same. So the whole point of 19 and 17 is that sometimes you have the choice between doing an explicit derivative and doing an implicit derivative. And even though, in the abstract, you'd probably rather do explicit, for this one, implicit would be much easier. That was pretty quick to do the implicit derivative. Doing the explicit required a whole lot of work. But they turned out to be the same, which was the point of that exercise. Let's do one more. Emily, you said 29?
Oh yeah, but it might be pretty similar to 27, I can't remember. 13 is also one.
Let's see, 13 versus 29. They both have a product rule involved in them. 13 has trig. 29 does not have trig. We can do one more. You got a preference on which one? Because they are pretty similar, like big picture wise. More to a calculus teacher, maybe not to a calculus student. $29. We did some trig already. Let's do a knock trig. Plus, it's cool that it's called the Witch of Agnesi. I don't understand why it's called that, so I couldn't tell you. I don't know if that's witch as in like the Halloween meaning of witch, or if witch has some other definition that I don't know. But we want the slope of the tangent line at that point. Let's see. Right away, we've got product rule. F prime is 2x. G prime is dy dx. So fg prime, x squared plus 4 dy dx, plus the other way around, f prime g, 2xy, equals, tried to warn us sufficiently on Monday, 0. Again, super common mistake, I guess because you get so focused on the hard part that you forget to worry about the 8 over there, but the derivative of 8 is 0. Let's show off our algebra awesomeness here by doing all this at once. Subtract the 2xy and divide by x squared plus 4. And then we want to evaluate that at 2, 1. So 2 goes in for x, 1 goes in for y, 2 goes in for x. And that's a safe stop, so we could leave it like that. CalcChat never safe stops. Negative 4 over 8 would be negative 1/2. So negative 1/2 would be the slope of the tangent line to this graph at the point 2, 1. And this one, because they give you the graph, you can see, I think, that kind of makes sense. I can get that picture on there. Nope, I guess I can't. So at 2, 1, the graph looks something like that, and I didn't draw that very well, but the tangent line slope would be minus 1/2. So that's in the ballpark based on the picture. Connor?
So if we were to be given the graph on the test, would we just do rise over run to find the slope of the tangent line?
Yes, but you'd have to be given. So the question was, if we were given the graph, could we find the slope by doing rise over run? Yes, if if you had a tangent line drawn in. Like, I'm not gonna, like, we had ones where we estimated the slope of the tangent line. So if I didn't give you anything else, then yeah, you could. That's what we did on this worksheet, where you didn't have an equation and you drew in a tangent line and found the derivative by using the slope. So if the question's like this, then yeah, your only option is to sketch in a tangent line and to use rise over run. But if you're given an equation, then we'll expect you to use the equation to find the slope. If you're given both, you can do what we did, and that is, find it the real way, -1/2, but also sketch it and see if that makes sense. Right? If we got an answer of 47, we would think, wait a minute, that slope, it's not 47, whatever it is. So generally, you get the most accurate answer you can. So if we give you an equation, use the equation. If we only give you the picture, then the directions are going to say something like estimate, because there's no way to get it. If you didn't have the equation, there's no way to get it exactly other than estimating using rise over run. So good question. Use the most precise method possible, I guess.